The mistake: believing the report without questioning the process. Would you like to learn how to read beyond a perfect inspection report and actually predict whether a supplier will run stable parts next month, not just today? If you're sourcing from India for forgings or machined components, I know your biggest fear: a quality surprise that stops your line and puts your name on the escalation email. My name is Rahul Agarwal, Managing Director at Prestech Forgings and Engineering Private Limited. I work with global teams every week and I see the pressure you carry. Cost targets, new launches, short lists to close, and stakeholders asking, is this supplier safe? The documents look clean, PPAP are approved, capability mentioned, certificates are attached, but your plant is thousands of kilometers away. Time zones stretch, response times. If something goes wrong, recovery is slow and expensive. So today, let's talk about a simple mindset shift. Do not buy documents, buy processes. Because your risk is not in the report, it is in what happens between two reports. Why do good looking reports still lead to bad parts? Sampling trap. A supplier prepares a golden bag for PPAP. Extra care, extra checks. Production next week is normal pace, normal noise. Measurement comfort. We trust the numbers, but we rarely ask if the gauges are repeatable. If the measurement system itself is shaky, all the data looks better than reality. It's a special case dryness. Forgings vary by heat lot, die wear, and operator. One heat with different chemistry or a die that was not preheated well on a Monday morning. And your fill changes, flash thickness, or micro cracks appear after machining. Outsourced steps like heat treatment, shot blasting, even final cleaning may be subcontracted. If their controls are weak, your final pass hides upstream variation. Distance bias. When you are far, you accept documents as a proxy for behavior. But behavior under time pressure is the truth of capability. I once saw a case where a supplier hit CPK on a diameter in PPAP. 3 months later, winter morning dropped shop temperature. Induction heating drifted and a small underfill turned into a big complaint. The report was fine, the routine was not. Here's the counterintuitive truth. The more perfect a one-time report looks, the more you should ask for everyday evidence. Real processes breathe. Real capability shows some scatter and strong reaction plans. Most escapes I have investigated did not come from lack of inspection, they come from lack of control. Consider a CPK of 1.33 plus means capability on a stable process. But capability without time coverage is a snapshot and not a movie. Ask for capability across multiple heats and shifts like GRR, gauge repeatability and reproducibility. To be above 30% can hide defects. Below 10% is good, 10 to 30% is borderline. If measurement is weak, capability is an illusion. First part yield and rework logs predict risk better than a single pass or fail stamp. Spikes in rework signal process drift. Tier 2 influence is real, up to one-third of defect. Causes I see are in outsourced heat treatment or machine. Use this 5P lens during supplier evaluation or quarterly reviews. It is practical and fast. P part. Define CTQs, few dimensions or properties where failure hurts you the most. Ask for last 3 months data on only those. Second P is process. Watch the actual flow in order. Raw material receipt, heating, forging, trimming, heat treatment, shot blasting, machining, final inspection, packing. At each step, ask what goes wrong here and what is your first reaction. Third P is people. Who sets the die? Who approves the first off? What training or checklist do operator use at shift change and tool change? The fourth P is plant. Look for controls and not posters. Induction temperature interlocks, die preheat records, tool life logs, coolant concentration charts, calibration status on gauges. Evidence beats policy. The fifth P is proof. Demand time-based proof. Run charts over at least 5 heat lots or 3 shifts for CTQs. GRR results for the gauges measuring those CTQs. Repair or rework percentages and top 3 causes in the last quarter. PFME and control plan revision dates with actual linked actions. Reaction plan examples. Show one real incident and how it was contained within 24 hours. Also align a simple contingency. If defect escapes, who is the person on night shift who can approve containment? Not just titles, names and phone numbers. A European agriculture OEM sourced a forged steering component. CPEP was fine. 3 months later, intermittent cracks after machining. Instead of switching suppliers, they applied the 5P lens. They asked for heat lot-wise run charts, die preheat logs and rework data. 2 gaps emerged: inconsistent die preheat on Mondays and no interlock on induction heating. Together they implemented a preheat checklist, added a temperature interlock and set a rule. First off approval per shift with go no-go gauge verified by GRR. The result: first part yield moved from 86% to 97% in 6 weeks. Complaints dropped to 0 for the next 2 quarters. The report did not save them, the routine did. The big idea: do not let a clean document lull you into a risky decision. Stability lives in habits, not in headers and stamps. If you remember only one thing, make it this: ask for evidence across time, multiple heats, multiple shifts, and confirm that people, not just paperwork. Know the reaction plan. If a surprise hits next month, what proof today would make you confident that the supplier will detect, contain, and recover without you escalating? I'm curious to know what's one silent risk you have caught only after the start of production, or what single question would you add to a supplier walk to see the truth behind the risk. Share your thoughts. We all learn from each other. See you in my next